Alright, let's go. So now, I told you I've made a video on naming hydrocarbons generally. I'm going to link that video in the description below so that you can see through it. But today we are just going to focus on naming alkanes right now. So let's say you were told to name this positive. You're told to name this alkane, for example. Positive. All right. So if you were told to name this hydrocarbon, what is the first thing that you should do? Identify the longest carbon chain. What did we call that longest carbon to carbon chain? Parent chain. Now, you know that with this kind of molecule like this, they've tried to confuse you in a way. So you think, for example, that the longest carbon to carbon chain is this straight chain. Let's count how many carbons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, as you see that it's 9 here, you think it's the longest, when in fact, and it's a long molecule, of course, because if you go like this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, that's not long. 1, 2, 3, 4, 5, 6, 7, that's not long, since we can have 9. But you will discover that if you go like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's C to H5. The two C's are hidden there. Do you understand? The correct form, the actual form of this to, structurally depict it is C2H1, 2, 3, 4, 5. Is that not long? Do you understand? So what they try to do is they try to compress it for you here. C2H5. Does that make sense now? So now now we have identified the longest carbon-carbon chain. So after identifying longest carbon-carbon chain, what do you do next? No, not number yet. First, identify the substituents. Identify what? The substituents. Now, the substituents are any other group that is attached that is not hydrogen. Any other group that is attached that is not what? Provided there is no functional group here. It's alkanes alone. So the functional group is single bond. Is that okay? So here, this guy CH3 here is what? Substituent. This methyl here is also what? I told you why it's called methyl, right? Right. We said the smallest alkane is methane, right? So if I decide to add a chain here, I've removed one hydrogen, right? So by removing one hydrogen, I form what is called an alkyl group. I form what's called what? So that meth, instead of methane now, turns to methyl. So those guys that are saying there, I'm calling them methyl for that reason. Are you getting me? Are you getting me? So that guy. Which other guy is a substance? Cl is a substance. Cl is a substance. But the remaining H's, they are not substance. Is that okay? All right. So having identified the substance, we will now identify the next thing, which is their position. Do you get it? Now, you have to count in a direction that will give those substances the lowest possible number. If we count in this direction, where will we encounter the first substituent? Let's go. 1, 2, 3, 4. The first substituent is on 4 now. Do you get it? I usually tell my students to use pencil to annotate. So to draw that distance. So how many distance? Let's go again. 1, 2, 3, 4. It's on carbon 4 that we have the first substance. And in fact, there are two substances on carbon 4, right? So it means that we have 4, 4. If we continue counting, 5, 6. The next one is on 6, right? If we keep counting, 1, 7, 8. The next one is on 8. Does that make sense? But let's see if we had gone in this direction, the other direction, the reverse direction, from right to left. So, yes. This one here. Okay, yeah, that's true. That's 1, 2, 3, 4, 4, 4, 5. God bless you. 5, 6. Do you understand? Notice I'm separating between number with what? Comma. Do you remember? All right. Why it is between number and letter? What do you use to separate? Hyphen. Do you understand now? So we'll come here again now. If we had numbered in the other direction, we are going to see, and that's one other thing to do. The number of numbers that you have here is the number of substituents you have here. Let's see. 1, 2, 3, 4, 5. 5 numbers. 1, 2, 3, 4, 5. 5 substituents. Does that make sense? All right, let's go now. Want to come from here? We're going to have, where are we going to encounter our first substance? 1, 2, 3. All right, so we have 3. Obviously, is the lowest. Let's go 3, 4, 5, 6, 7, 7. Whoa, that's big. Okay, let's do the addition and see which one gives us the lowest possible number. Now 4 plus 4 plus 5, 13 plus 6, 19 plus this, 27. But let's add this. 14 plus 7 plus 7, 14 plus 6, 20 plus 8, 28. Whoa! You know, one would have thought that this direction was bigger. So which direction are we picking? The first one. The one that gives us the lowest possible number for the substituent. Does that make sense? All right. Oh, I'm not supposed to clean it, but let's take it. Let's use it back now. So we can go on to first writing our substituent and their number. So for example, substituent is on 4, so we go 4, 4. How many guys are there? 2 chloro, right? So then what do we do? Dichloro. Do you get this? Between number and letter, hyphen. Let's go to the next one. So the rest are methyl, right? And those methyl are on what? 5, 6, and 8. Exactly. Trimethyl. Does that make sense? So you now check between these two, 4,4-dichloro and 5,6,8 trimethyl. Which one is alphabetically should come first alphabetically? Di. Does that make sense? So our name, the name of this molecule becomes 4,4-dichloro hyphen again 5,6,8 trimethyl. How many carbons? 10 as decane. Is it clear? All right. Let's name one more. Now, let's name this one. You see, this one has a lot of bends and kinking. Now, this word, kink. What do I call it? Kink means bend. So, it's kink. There are different kinks here. So, another kink going up. So, now, how do we name this? Identify the longest carbon-carbon chain. Now, where's the longest carbon-carbon chain? Let's see. 1, 2, 3, 4, no. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Now, notice that the direction does not matter first, right? We just want to first identify the longest carbon-carbon chain. And that is the longest. Is that okay? If we come from here, 1, 2, 3, 4, 5, 6, 7. So that's still the longest. Is that okay? We'll now circle the rest as what? Substituents. So this guy is a substituent. This guy is what's the name of this guy? A substituent. Methyl. How about this guy? Ethyl. C2H5. You understand? Ethyl. How about this guy? Bromo. Good. Bromo. Now, if we number in this direction, when are we going to see our first substituent? On what carbon? Carbon 1, 2, 3. The next substituent, carbon 4. Next substituent, 5. Next substituent, no. Okay, we have 1, 2, 3. Okay, so it means we have 3 substituents. That's 1, 2, 3, right? Okay, that's it. Let's go from this direction. 1, 2, 3, 4, 5, 6. So you see, looking at this, because it's compressed, you might think if you go from here to the slower. So you have to check well. Because here, this will give us what? 9 plus 3, that's 12. Here will give us what? 15. So we're using the first one. That goes like this, right? Goes rightward. So let's go now. We have methyl, right? Between methyl and ethyl, methyl appear once, this one once, bromine once, right? So we can easily say, we just arrange that. Which one should come first? B. This one is ethyl, right? This one is methyl. This one is bromo. Which one should come first? Bromo. Bromo is number 5, right? 1, 2, 3, 4, 5. So that will be 5. Bromo, not capital letter B. Bromo hyphen 4-ethyl 3-methyl exactly octane. Octane. So that is the name. Do you understand now? So that is how to name it. I'm going to give you classwork now, and you name it. Okay, no. Let me give some questions. Pause it. Let me give you some questions, and you will answer them. All right. Now, these two questions will I give you to use to practice. All right. Drop, for those of you that stuck to the end of the video, make sure to also do this too and post your answer in the description box. If you have any other question, do well to ask. God bless you. Then subscribe to the channel as well.